So we have Sean Gelder on the left, someone we never grow tired of, Sam Hagerman, Gavin Healy, who you saw this morning, Rick Blumenthal, whom you heard at lunchtime, and you can hear some more tomorrow, and James Bill at the far end. And our moderator will be Craig.
Well, we know all the game rules from this morning. Let's just jump into it and make the best use of all the time. So, okay, again, starting with historic detailing and so on. There's even more insulation, air infiltration breaches here. And actually, Rick, this morning we had to review, everybody on the panel kind of takes a shot as they see fit at the slide that comes up. We start with the older slides and move our way.
Oh, you don't start with the older guys?
The slides. No, it's not your last experience. It's the building we're talking about, old. So, and we poke it around and stuff, and basically the slides are here to induce a conversation. Initially with our panel of experts, and then with audience. And we go through slide by slide, and I provide some direction when appropriate, and sometimes they even raise my hand. So
for you, we're going to rely on
we have a. I could speak louder.
It's right over there.
So the eave block, the freeze block with the drilled hole in it is creates a challenge for air baffling and keeping your insulation working.
Testing. Yes?
Okay.
So, and in this particular instance here, you'll notice it's not a raised heel truss, it's not an energy truss. So you got a lot of issues here. And if you were going to baffle this without changing the screen bird blocks in it, the only thing that you could really do without doing that would be to put it on an angle up to a 2-inch. So you would start it at the bottom of the inside of the bird block, and you would run it maybe a board, a piece of OSB or some such thing. Where we are, we use a lot of cardboard, which is not a really good baffle to use because we have a lot of rain where we are and a lot of mist that gets inside, and then the baffle gets wet around the fasteners, and then it falls down, and then you get all the wind washing going on. But to baffle this thing, you could put an angled baffle from the bottom up and hold it down 2 inches from the top of the sheathing. Of course, the problem with that is, in this condition, is it's not a raised heels truss. So you're going to, thank you. So you're going to lose more insulation by putting that in there that way. But it's pretty much the only way to do this without ripping out the bird blocks and screening them the top, like Gavin was saying.
Could you put a right angle baffle? If you made a right angle baffle?
Sure.
Yeah. So we sometimes cut the baffle and so that that baffle is 1 inch away from the.
Yeah, and it would just come straight down. So it comes up like this. Stays 1.5 inches away.
Sure.
So how do you suspend? How do you hold that in place?
Go ahead.
Usually, what we do is we tack it up with 1 or 2 nails on the side of the truss, and oftentimes we're using foam board there because we can get out of 1 inch or 2 of foam board doing double duty as the baffle right in that peak, which is the worst thermally, down at the bottom there. We can get the most amount of R value that we can out of that space.
Anyway you slice it, it's a pain in the ass. You have to go to each bay and do something with a bunch of little pieces. And it's really uncomfortable, and it's dirty. And
that's if they
yeah,
drill every day.
There's no way you can do that work accurately.
And it's typically worse than the drawing because usually in a hand-stacked roof you don't have the ceiling joist line up with the rafters, so now you've got another framing member coming in this already difficult area, and right behind there is a bad air leakage joint. Basically all the way around that whole picture frame is bad air leakage down into the wall assembly. But when we do have success at fixing this, we oftentimes talk to our customers and show them in infrared the benefits that it has to the whole wall assembly. So even when we're not repairing the wall assembly, limiting that air infiltration from the top plate has a big benefit.
Well, how are you eliminating the air sealing the top?
We basically connect we air seal the drywall lid to the plate here,
With
and any number of goopies, and then the plate to the sheeting out here, and then we trace around this block, whether it's a freeze block or a drilled block, because the freeze blocks usually have a 1/4 inch gap around those, and those all let air infiltrate around your air permeable insulation and degrade the quality, and then we baffle and seal the baffles tight to the rafters on either side, so that there's no bypass.
That's a huge bang for your buck in air sealing right there. It's a real pain to get to, but it's very productive to really cut down a lot of air infiltration at the joint at the top plate. It's a big leak.
Yeah, because the drywall I mean, when drywall goes up against top plates, it gets nailed up and fastened, but absolutely what happens is there's a gap in there, and then the pressures of the attic wash that cavity.
You've got wires and plumbing and vents coming
Right.
through there.
Just as a point of information, in a colder climate, we'd get some people in to take all this insulation out
Yeah.
and then vacuum this whole attic space. And then we'd put a baffle in here all the way up and then come in and just cathedralize this whole thing with spray foam, which is a real common retrofit detail like in Canada South.
Closed cell or open cell?
Well, it depends on who you talk to. I prefer open cell just because closed cell's got a much
Yeah.
more.
Question.
Yeah, carbon footprint. Yes.
Why do you baffle it if you're going to use insulation? I mean foam insulation.
Because I'm using open cell foam insulation. Potentially, there could be enough interior to exterior moisture drive through that open cell insulation to condense on the cold roof membrane if it were.
Sure, but you can just use 1.5 or 2 inches of closed cell to minimize the GWP of the closed cell insulation, and then just fill the rest of it with open cell.
Yeah, you can do that.
Is there a
It's
reason
two,
you don't do
yeah,
that?
2 different trucks, a different trip charge. I don't like closed cell at
Yeah.
all, so it's just personal, I guess.
So is that why when I've seen a line of damp, I come from damp, you know. When I've seen a line of damp between the ceiling and the wall around in a room, is that coming through there in that location?
It's hard to
Yes.
say. I don't know if it's coming through there rather than it's interior moisture condensing there because that's a cold spot.
That's the reason.
But it's coming from the same unfortunate detail.
And a thermal bridge in your case, yes.
Yeah.
Yeah,
Yeah.
that's the reason.
Well, and it could also, though, be the warm, moist air from the building finding its way into the wall cavity, going up and condensing against the roof sheeting or roof sheeting nails and dripping back
Right.
down.
Yeah, that could be it too.
Same thing, but just a little bit deeper. in.
Right.
It's a weak corner.
Yeah, it's a weak corner, and it's complicated. There are a lot of little tiny parts and pieces that
Yeah.
have to fit just right and have to be executed just right in order for it to work, because it's easy to spend a lot of time on this stuff and not get where you need to get.
Why don't you just caulk up there on the retrofit and then paint?
Well, because it's a damp thing.
It's thermal bridging, it's air infiltration, it's air exfiltration, and the exfiltration may contain a lot of moisture in it, and anytime you have a temperature difference.
What I'm saying, you're gonna need a caulk around the whole thing,
So what happens behind the drywall? It's the
That's
same,
where the
it's
problem
the
is,
same.
is behind the drywall.
It's at the connections for all the wood framing
Yeah.
is where the problems are.
Yeah.
The drywall is already taped. So unless it's pulled away, it's effectively an air barrier at that point. So putting a bead of caulk up there it's a symptom correction for a symptom, but it won't work because the issue is behind the drywall.
Does that make sense? The corner on the inside isn't leaking any air through the drywall corner. It's leaking behind.
Understand.
Yeah.
Could you explain the difference between open and closed cell? Why one would be better than the other?
Well, closed cell is better for some things, just given the application, because closed cell will not allow water vapor to penetrate. In fact, it's often considered a waterproofing layer. It's vapor closed, so nothing can dry through it, nor can water make it through. We use it sometimes in basements against walls. It can form a really heavy-duty plastic layer. It is plastic. It's field catalyzed plastic. So open cell is the same thing, just less dense. Some people refer to it as 2-pound closed cell versus half-pound, which means the material that's closed cell is 2 pounds per cubic foot, and the open cell stuff is a half-pound per cubic foot. So it's just sort of a frothier, more open thing. It's kind of the same. They're cousins to one another, but one has way more air in it. Therefore, air can get through it a little bit more, or vapor can get through it a little bit more.
So, one counterpoint to spray foam would be in terms of, because it is a field applied application, if your field and pliers are not really on top of it, it's beer 30 on Friday or whatever, you could have some pretty bad consequences associated with two chemicals going together in the wrong fashion, and they can be very expensive to pull out foam if you need to pull it out because it was applied wrong.
There can be long-term outgassing effects, which are
That's the other question.
There can also be fires. There can be all kinds of weird stuff. There can be, they can go in and look fine, and then 3 days later you go back and it's contracted by 50%, which means it's doing nothing.
High GWB.
Yeah, some of the blowing
very,
agents.
very high. Even a water-based blowing agent, like in an isonine, if you will.
Yeah.
There's still a manufacturing process that releases all of those toxins into the atmosphere. Some of them are cleaned up. But from the manufacturing, and it's a petroleum product. These are all based on petroleum products. So from a sustainability standpoint, on a scale from 0 to 10, it's -100. It's high global warming. It's not.
That's definitely
it's
true.
Not nice stuff.
It's hard to find. It's hard to find a justification for any spray foam installation where its merit is simply thermal. It's impossible to find a justifiable application for closed cell foam in most cases, from a holistic standpoint, in my point of view. This is point of view stuff. So I agree.
Yeah, and I'm sorry, go ahead.
And the other reason people try to use it is for air sealing, but it's not a great air sealing because it's not going to sustain a hold on the wood framing that it's trying to air seal against. So it's not even that one. It used to be that's what they were a lot of times advertising.
Now, obviously, if there were representatives here from companies who made this stuff, they would disagree with the changes.
Yeah.
When I used to own a foam rig, and I got rid of it, and the issues we found in terms of like when was appropriate and when wasn't appropriate to apply in terms of temperature and substrate, relative humidity, and a variety of other factors. Those are the reasons why we got rid of it. But if you did blower door test after blower door test and you were using foam as an air sealant, for instance, anybody who pays meticulous attention to air sealing can get it right with just about anything. Anybody who doesn't pay attention meticulously to air sealing is likely to not get it right. And the problem with not getting it right with foam is it's hard to correct, because usually what happens is the air leakage paths are now totally obscured and you have no access to them.
So how about unvented cathedral ceiling? What would be your recommendation for insulating an unvented cathedral ceiling?
Legal or not?
Yeah, like a dense pack fiberglass blow-in. Like
Dense pack fiberglass bib system.
With a smart membrane on the bottom.
A vapor diffusion vent.
Well, you don't need to do that if you're going to do an unvented roof assembly, it needs to be airtight.
Yes.
I mean airtight. It has to be really airtight. And when we go to roof-to-wall details, there's probably going to be some discussion about how those connections are made for the skin, not the framing, okay? If it's airtight, then you want condensation control on the top of it. And at least in Washington State, we use a scale that's right out of IRC for condensation control. Depending on your climate zone, you guys are different. You've got 16. Everybody in the world has 8 climate zones. But California's different, so what, who cares? But depending on your climate zone, depends on how much insulation you need exterior on top. That prevents the dew point from staying on the underside, the first condensing surface of the roof sheathing, and moves it out into the middle of the foam somewhere. So the higher you are in the climate zone, 8 is colder than 1, the higher you are in the climate zone, the more condensation control you need on the top, and you can fill it with any fibrous insulation. Of course, I'd recommend glass in a blown-in system, but you can use any fibrous insulation as long as you have really good condensation control, and a dense pack is always going to perform better than a pack.
No, so that's the building science comeback to that is that keeping the sheathing warm is only part of that whole assembly because no one believes you can build an airtight structure. If you actually build airtightness and you trust it, you can't move enough moisture to that cold sheathing to ever hurt it. And if you're building your detail to the outside properly where there's enough drying potential on the outside of the wall, the sheathing can dry to the outside. And there's lots of buildings built by talented people that have cold sheathing with no insulation and they're doing just fine. So, you know, it's just one of those things. It's like if you go down that path, then you better better fail safe on putting more on the outside rather than not enough. Because the worst thing you can do is kind of get a little bit of air leaking and then make the sheathing kind of warm, but not really kind of warm, but just perfect for mold growth, and then further retard its drying capacity. And then you've gone backwards by trying to overheat the sheathing, whether it's roof or a wall. So, I mean, that's just knowing what the physics are and making a decision as to what your air tightness strategies are, how durable they are over time, all those sorts of things go into all choices of these components and how we put them together and how we stage them.
To do a code legal application in California, that way you'd have to go over with R5 no matter what climate you're in California, and no matter what the depth of your rafters are, which makes no sense at all from a building science standpoint. The deeper you get your insulation rafters, the more you're retarding your heat flow to the sheeting, and so your foam levels should ideally adjust based on the climate and the depth of rafter if you're going to go over it with foam.
Yeah.
And the situation changes
I would say the
dramatically.
foam's hurting.
The situation changes dramatically when you go to a vented assembly and you're using insulation on the lid. Because adding more insulation can create more problems if you just add more insulation and don't do air sealing at proper spots, even in a vented assembly. You can have a lot of moisture coming up from the inside.
So the other
Create
part of,
problems.
so the air sealing is super important. Trying to get the moisture out of this. You don't ever get that condensation back. But it's like you said, it's really hard to do that. So the other part is there's a lot of intelligent sort of vapor airtight layers that will allow moisture to come out in different scenarios and different temperature. The other, I just wanted to nail one last nail in the coffin on these spray foams. I believe they all still have flame retardants in them, which is hugely devastating material to be spraying loose in your house and killing your workers and everybody else. So it's like not a great material.
I'm going to move the slides forward because the slides have fallen behind the conversation.
Yeah, what do we need slides for?
I just want to catch up. Well, visual aids for everybody.
If anybody is interested, tomorrow afternoon I am presenting, and it is not glass biased, but it's not possible for me not to be it's a comparison of the main insulation materials that we use: open cell, closed cell, cellulose, glass, rock, rigid boards. So there'll be enough information there in the hour's time that at least you can get an appreciation for how these things are different. And I want you to think about this if you decide to go to my class tomorrow. I want you to think about what the best insulation material is to use. And you're not allowed to talk to anybody, you just have to think about it. And you can't answer the question until the end of the class. So think about it. You're talking about an unvented assembly?
Vented?
Vented assembly, yeah. It'll add, but small amounts.
So what I'm suggesting is that if you have thermal insulation that's up to the task of mitigating for 140 or 150 degree attic and air leakage control, the radiant barrier doesn't matter.
Oh, but it's still working.
but it's not doing anything for you because your thermal insulation is already doing what you need.
So you have extra insulation. More insulation than you
There's
need.
no value added is what Gavin is saying.
Well, it's almost a belt and suspenders though, isn't it?
Well, I
It is,
would,
they're
at
adding
a
improved
cost, right?
properties.
Well, if you
I
could
would agree,
subtract
but at a
insulation
cost.
and add radiant,
Yeah, right,
cheaper.
yeah, there you go.
it's about your rate of return
Yeah.
over time.
And,
Yeah.
and is it a net benefit in both seasons?
Well, there's not much heating effect from a warm roof in the winter because you still want enough insulation for night sky radiation.
So our insulation either works or it doesn't work, and where it works the least well, that's where a radiant barrier works the most effectively.
Exactly. It substitutes.
Right. You don't build in the valley as much as we do. But we can continue this later. So here's a new visual aid. There's one giant hole in this. Point it out.
It's the same hole, isn't it?
Andy.
And the sheeting's missing off the insulation on the top. That's-
Well,
There's no air barrier on the outside part of the insulation in the soffit.
and so what might happen in this assembly in the real world?
Thermal chimney, warm air rising would be one.
Bingo.
Air blowing, going the wrong direction through your insulation, or going
Yeah.
through the insulation, wind washing.
It's a fabulous breach of loss of control of air through an assembly. Since there's a hole, an undetermined amount of height open from every single stud cavity bay into the eave soffit and into the roof.
And the rest of the cavity's not tight, so
Right, right.
come in for the chimney.
So my second question is, would the same thing happen if this soffit was on the inside of the building?
That's what I'm used to.
And this doesn't happen so much anymore, but I've seen this built on houses that are 30 years old, and it's egregious. It has to be taken apart and put back together to control anything. Anyway, but I'm
So what Clay's, I'm sorry, what Clay's talking about is a six-sided assembly.
Right.
It's really that simple.
Yeah.
It's also required in QII.
I think that the challenge with it in the real world ends up being that the person who's left to make the decision on air thermal boundary alignment is paid minimum wage by the piece to put insulation in as fast as they can. And so if it's not addressed by every person along the way, particularly the person who's putting the frame together, that's the responsibility of the architect first, but then the framer to catch those sorts of things because they're creating that container.
Right. And basically, every professional along the way has a finger in the responsibility, and one can make up for another if they catch it soon enough.
Right.
But in fact, the best scenario is everybody's doing their job to the best of their reasonable ability, and buildings will come out better, guaranteed.
Well, I think if we just simplified our energy inspection process and required all buildings to have a target air leakage regardless of how they model in Title 24 or whatever, every building has to be, you pick the number, I don't care, 3, 5, 2, 1, 0.6, but right now the variance of air leakage is from 3 to 25 in buildings built under the same code on the same day in California. So.
Right.
What a concept, a performance measure.
Performance-based
Oh my
measurement.
goodness.
You can't provide quality without a measurement,
Yeah.
because you have no idea what you have unless you measure it. So the difference between prescriptive permitting and performance permitting is like baking a cake. Prescriptive permitting is a list of ingredients that are supposed to meet a base model that the CEC put out. And if all of us had the same ingredients, the same oven, the same kitchen, the same amount of time, the same temperature and pressure in the room, all the stuff that matter when you're doing cooking stuff, and we all bake the same cake thinking we're baking it the same way, I would guarantee that most cakes in this room would taste completely different. Okay, and that's prescriptive. There's no way to test it. So performance-based, you have to taste the cake. That's something to think about. And the only way you know what you have is to test it. It's the only way to do it.
That's not to be confused with performance modeling in California, which we also do, which is still prescriptive.
Right.
Yeah,
It's a
that's really
prediction.
confusing.
So I have a piece of advice for the designers in the room, particularly that, well, what can I do in this scenario? You can put a specification on your plans for a target ACH rate. And you can know what it means, and you can be responsible to tell your client that this is why we're doing it. It's a measurement of a quality of performance and installation of the building. And you can tell them why it matters, and the contractor that gets hired will be folded into that process, even if they weren't familiar with it before. And they will push to meet that. And this is separate from certifications and incentive programs and so on. This is a qualitative measure. The designers bring forth information to design better and better buildings. This is one of the measurements. We can put that on our plans right now. I've done this, and it brings the standard up, and it takes some follow through on the designer to stay with it, but it produces better buildings.
If you wanted to take it easy on the crew, you'd recommend that they do that test before insulation is in place.
Absolutely, absolutely.
And you need to draw your details so that they don't look like this.
Yeah, we wouldn't use details like this.
Yeah.
You can't expect them to get
When I-
anywhere near anything.
When I mentioned you having to put the airtight barrier through the cross-section of the structure to get it pass-fail certified, you'd have to draw the airtight barrier on that drawing.
Right, and you can't draw.
Which is impossible.
Right.
That's a sign that it's wrong.
Right. One of many. So this is a cathedral ceiling from 30 years ago. Well, they don't show the insulation.
Or the drywall, but.
Or the
we're assuming
drywall,
it's different.
yeah. But they did use those materials in the construction of the building. So let's make some basic assumptions.
Yeah.
So we have fiberglass bats in the 2x4 walls, only a 2x8 rafter, so you can fit R19 up there. And it's a vented assembly.
What's a 2x10 wrapper?
2x10. Oh, good point, thank you.
2x8.
So we could squeeze a little bit in there. So someone tell us about six-sided structures again for insulation.
Well, I guess that's me, I mentioned it. So a six-sided structure, just take a wall cavity. You have 6 sides on a wall cavity, right? You got the exterior sheathing, that's side 1. You have the bottom plate, that's side 2. You have the top plate, that's side 3. You have the stud on either side, 4 and 5, and your air barrier drywall on the inside face. That's a 6-sided cavity. So we really do need 6 sides. And one of the ways that, and I don't know if you're going to get into continuous insulation, we'll talk a little bit about it tomorrow, continuous air barrier.
Mm-hmm.
Gavin mentioned it a little bit. But take a kitchen soffit, ceiling soffit, where you're going to run cabinets up to it. If you don't put your drywall or a rigid board behind that and seal it up, you have a direct connection from that assembly right to the outside or to your attic or both. If you have can lights in there and you heat them up with luminaries, now you got really nice chimneys. So that brings us to airtight IC cans. How airtight is an airtight can?
QCFM at 75.
At 75 pascals.
Installed right.
If it's installed right, it's allowed to leak 2 pascals at 75, 2 cubic feet a minute at 75 pascals of pressure. So what that means when you're doing a nice custom home with 235 cans in it, multiply that times 2 when you got a 30-mile-an-hour wind outside, and you're in trouble. You're in big trouble. So you still have to deal with the cans. Same as the continuous air barrier in the 6-sided assembly. You've got to get that thing sealed up. And if you don't, you're going to run into moisture and infiltration and exfiltration problems along the way.
So is this a six-sided box?
No.
That's not.
That's the point.
The detail that was almost never drawn on any of these images was oftentimes we saw the squiggly lines for the bats that were installed, but we never saw a layer that separated the vent channel from the bat itself going In this case, it's a cathedral ceiling going from the eave all the way to the top.
Right. So the,
Well, I'm seeing the six-sided, we're assuming drywall's on there, right?
yeah,
So the wall's six-sided, right?
the wall is six-sided. The rafter bay does not have a top because the insulation is exposed to the
The insulation
draft
and the
air.
rafter bay.
The insulation won't go up to the top.
Right.
That'll be
Because then
internal.
it
So,
won't be a
devil's
ventilation.
advocate, if that insulation is really just follows the top of that 2x8 line up and we have a perfect ventilation cavity and the insulation lays in there perfect and flat and it just stays there, that's a pretty good assembly, I would say.
Because wouldn't it be
Kinda
the same as insulating your ceiling? Assuming
Yeah,
your
the
ceiling was all
ceiling's
sealed
insulated,
off,
the sheathing's cold but ventilated.
you're just tilted instead of being flat.
Kind of.
It'll work.
The key comment was it has to be perfect.
Yeah, I know it's not possible, but I'm saying in theory, that works.
But the weak link, it would work better if it had a lid on it. And that lid prevents convective loops through the top layer of this fibrous fluffy stuff. So without that lid, and especially with a draft of air washing across the top of it. Say it's a cold winter night, you have your...
loop through your fibrous material?
No,
What do you have to say about that?
Dense packet, I can show you the, I can,
Right, it was dense pack.
So you're gonna dense pack it in the vented channel?
why not?
So,
Been done before,
Why
right?
couldn't vented?
We haven't detailed the dense pack that, but it's just got a rigid channel.
right, yeah.
Right.
So,
I'm with you, I'm just,
So here's,
we can move on. You don't spend any time on my tomfoolery.
I know, but this next slide is associated with this.
Maybe once you get the drywall on the inside of the bottom of the rafter, you know, you need anything hole in that thing with like an electrical box or anything
Right.
in there. It's
Yeah.
You've
All
reached,
layers
yeah,
constant.
yeah, there's a hole in the bottom of the ship.
I have one other comment on that. How do you get the ply, nailing, shear to the block at the top of that big of a gap?
Not with this detail.
What do you need that for?
What do you have?
Yeah. Yeah.
Everybody is actually assuming that it's best case because they keep on saying drywall on the lid. Usually it's T&G wood with no
Yeah.
drywall.
That's for ventilation.
In this era, that was very common.
Double,
So-
two-sided
so-
ventilation.
So keep this image in mind. The next slide is at the top of this rafter bay cavity.
Oh, that's terrific.
At the top, that's a clear stereo wall. So what is wrong with this picture? I heard it. Who said that?
No.
Bingo. If you don't have ventilation at the top, it's not a ventilated assembly. What might happen with a non-ventilated assembly that you thought was a ventilated assembly? Experts?
Everything you don't want.
It falls down.
UCSC,
Yeah.
at UCSC, they rotted within a year and a half.
Yeah, these rot.
Yeah,
Big
at the
issues.
top.
Huge issues.
Fortunately, the bats in the wall are probably not that good and it vents out the wall assembly.
Yeah, I mean, honestly,
There it
in
is, perfect.
the real world, the framer did a really crappy job, and there's some air leaks at the top of that plywood seam.
So it's venting.
Nobody sealed the plywood up to that
Right.
beam. There's probably another piece of plywood on the face of that beam.
Yeah.
There's a bunch of air leaks, some overdriven fasteners.
So poor construction helped to survive
Exactly.
endurance.
Yeah.
Comment
Yes.
on flashing number 33, they do make a flashing now with ventilators.
Yes, they do.
Yeah.
There's a couple of them out there.
I've cut Corbin's now, it's stuck on top. Cut that sheet.
Okay, take a shot. Some background information. This was a retrofit situation
What climate is it?
at North Coast, halfway to Portland.
You can see, is there a sheeting layer going over there?
There's two sheeting layers?
Yeah, what is that sheeting on the
Fire
bottom?
retardant sidewall shake.
This is cheating.
No, up and
On the roof.
up below
Yeah.
below the poly.
Okay, this, actually, I didn't label this one. The first layer is skip sheeting, actually, which is important.
Oh, it's good sheeting.
Skip sheathing.
So we're keeping
1x4 with spaces.
Oh, because it's
We'll keep-
retrofit.
Yeah.
So that was original.
The original roof was shake roof. We pulled the shake roof off. we
Needed
put
to
rigid foam on
over-insulate
it.
for continuous insulation.
Yeah, yeah,
Yep.
yeah.
So, I'm confused a little bit. EPS is expanded, and XPS is extruded, and you've got expanded up there. One is a closed cell, and one is a bunch of little tiny round circles with holes between them put together. Okay, so you've got a permeable insulation there with also a lower R value than closed cell insulation. I mean, that's one thing that I would change. There's, it doesn't look like there's a slip sheet called out underneath. There's no underlayment underneath that either, between the top of the sheeting and the underside of the EPS. So you could have a lot of moisture and transfer in either direction there. It's not an airtight assembly. Well, I'm assuming it's not an airtight assembly. And it's unvented. You can see that it's unvented.
Yeah, this is an unvented assembly.
Well, that's, you know, that 2 inches of EPS, even if it's
Yeah,
just
probably,
sheets, it's
yeah.
pretty good air barrier.
Yeah, it is.
In that climate zone, you're probably right.
Yeah.
But the skip sheeting creates a bypass between the layers unless that's blown insulation that fills,
Yeah.
It's fiberglass.
it's bats.
Bats,
So
probably.
there's
Bats.
there's like 1.5 by 2 inch air channels running between the EPS and the fiberglass
Yeah,
Horizontal.
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 Well, they
It's a
go at the
compromise.
end of the building, so.
Yeah.
I don't think it's gonna fail.
I don't
think
either.
it's fine.
Yeah, yeah.
I think it's leaky enough.
See, and again, every one of these is some set of compromises with base conditions and goals and how far you're gonna go. You've used that expression, you know, how far to go on various things.
I mean, I guess I'd pull that back if it had a layer of continuous, like a bitch-a-thing membrane. If it had a real continuous
Yeah,
waterproofing, if that were asphalt shingles, I'd be fine.
I mean, you're thinking like ice and water shield.
Yeah. I don't know if ice and water shield might allow enough stuff to collect in that system and not dry out, that it might be a problem.
I guess I just would have netted over the skip sheeting and blown the bats in solid.
Yeah.
Yeah, that would have been cool.
that would have been better.
Put the drywall up and then,
Well, I'm assuming the drywall's up and this was retroed from
oh
the
yeah,
top.
yeah, then blown in those, yeah, that'd be better for air too.
Actually, the drywall is not.
Well, you could put it up and then finish the roof.
Right.
So if the drywall wasn't up, you could net it.
Yeah,
You
yeah.
could just net
You're
it
right,
and
you're right.
and then
Yeah.
pack it with your favorite material.
Yeah. Okay. So I think I have a.
1,000 bottles?
You could put 1,000 bottles in
So this is the third image, which is more better than,
The lines are all continuous.
yeah. Okay.
You got a dew point in the sheeting, I mean, in the foam, yeah. It worked. Did you do therm before you built it?
No, I
Yeah.
got lucky.
Yeah.
I'm using therm more now.
Yeah.
SIP panel construction. I have plenty of opinions. I'd like to know yours about the weakest link about SIP panels. Anyone who wants to take a shot.
The wedge right there where the panel comes down to the top
Yep.
plate,
Yep.
thermal bridging.
There is some, yeah.
Weakest link is they're applied with a really expensive crane, so nobody wants to take the time to do them right when they're going in. They want to get the crane off site.
Actually, that wasn't a problem on this job site. The contractor first rented and then bought his own long reach man lift. And they set all the panels with a man lift because the panels were light enough. It was just 2 more people in the cage, so they only had 1 guy in the cage driving with a panel underneath him, putting it on the roof.
So typically, the weakest link is the crane.
I disagree.
No, cranes are cheap.
I think
Cranes
that-
are great.
I think that the weakest link is the perfect example that happened in Alaska many years ago when they put the SIPS roofs up. And the problem with the SIPS systems is, first of all, there are 3, maybe 4 now different spline configurations to connect the panels together, end to end. They connect like this. There are a number of different configurations you can use. The simplest one to use is to use a 2x, it's usually a 2x6, not a 2x4, and there's a channel cut in each end of the panel, and then you slip your 2x
channels cut into the
insulation. You have thermal bridging on either side. It's the same amount of insulation. The biggest problem is the pookie. You can't get enough pookie in those joints in the right places, and then shove this thing in. And we can talk about how caulking works and doesn't work. Okay, you've got to have a particular shape for it to work. So when you put all these things together, it squishes all the pookie, all the caulking, all your sealants inside this assembly, and they leak. And then, of course, in Alaska, they put the tape on the wrong side. They put it on the top side instead of the bottom side, so everything from the inside came straight up and came to, and then wetted all these nasty tapes that don't stick anyway, and then everything leaked out, and then the entire top of the sheathing rotted. And they had hundreds of these homes, maybe thousands of these homes with these kinds of problems, because the connection joints between the SIPS panels are the most difficult thing to achieve correctly.
And that's exactly my same opinion. And taping the top, which is where people, oh, okay, my air barrier is going to be at the top, is the wrong place because of the warm, moist air, particularly in Alaska. People get sweaty, even in the winter, and cook and so on, and the vapor drive is pushing up, and we'll find every joint.
SIPs are tricky that way because you have to move it all to the inside.
Right, right,
Put a
right.
surface cavity to the inside of that.
So on this project, at the ridge, I specified that the contractors would drape a peel and stick over the ridge beam as they set the panels up, and then we wash that, because that's the hardest one to hit.
Yeah.
And then after
so
that,
sticky side up, drape it over.
Sticky side up. Yeah. And then all the other joints they hand taped because they had access to them. But in fact, it would be a very good candidate for some sort of field applied high pressure sealant for all those interior joints, because you can reach them all.
That's right.
So
thank you.
Yeah. And actually, that would have been a good project to do that.
Yeah, and you know what? We should test it on that. That's a great idea.
Yeah.
That's a great idea.
Yeah. So,
plus that handsome blue color would look really good against the.
Right.
A lot of the SIPS roof assemblies in our neck of the woods test out somewhere around 6,000 to 8,000 CFM50 leakage, and that's typically because the builders don't understand the transfer of air barrier from the wall to the roof line.
Yeah.
Now, your point of like draping something over the ridge beam, it's just like an interesting part of the whole constructability of an air barrier. It's like, how do we get from here to there without, and still build the wall?
Right.
That we it's usually typically there's like some little layer that we stick in somewhere to make it work.
Right.
And it's really a cool, simple trick. And it's just easy, it's cheap, it's, and it gets
I like that.
And again, it's coordination between all the professionals involved in the building process, because we had a good contractor who would never built a SIP panel project, but was willing. That went and learned all sorts of stuff, and then we went further, and we had a lot of communication on the site and before construction about these things. And he says, "Yeah, that makes sense. I'll do that." He'd never built a SIP building. He'd never draped that stuff over the thing, but they saw the reasoning why, and they wanted to build a quality building, and they're all in.
Yeah.
This is their first shot, and we got it down to 2 ACH.
And that's the important thing about finding a contractor, really. So we don't want to find, there's nobody out there, I don't know everything, they don't know everything.
Right.
So we all don't know everything, but you want the one who's willing to try something different, who's willing to be interested in experimenting and curious. That's, it makes it complete.
Yeah, it takes a village to build a house.
Yeah.
Just a comment. I'm sorry. Just a comment on the SIPS panel. The other issues with the SIPS panels is, unless you build another wall, a redundant wall inside to run all your gear, all your wires, or your pipes, mechanical and what have you, unless you build that wall, then you're actually carving out your insulation to set that stuff in it. So a 6-inch wall with a 1-inch cut out of it is only a 5-inch wall. And if you're using a SIPS panel, it's generally EPS, that's an R20, not an R24. Because you just cut an inch out of it, and think about how much of that stuff is cut out of the wall and what your total R value, or better yet, your U value becomes.
Yeah.
I mean, it's a double-edged sword. And even in a perfectly built assembled wall for an volumetric project, in a perfectly built assembly, you will never achieve the rated R value that's on that product. It won't happen.
Yeah. And that is the other weaker link. It's not as absolute as the air infiltration through the lid. Is electrical. Plumbing, don't even put it in a SIP panel. That's stupid. But electricity we generally need around perimeters of buildings. And that in this project, which was fairly complex, the electrical contractor had a 30% higher cost for his trade because of the labor and effort to snake things around.
And if he has to use pipe, you've got a more conductive product right there too.
Yeah. Right.
So,
yeah.
Another detail that often happens wrong is when you're passing insulated pipes through the assembly, the insulation on the pipe, like say a line set that passes through a SIPS assembly, the pipe itself is the air barrier, and connecting the pipe back to the sheeting, if you're drilling a 2-inch hole and relying on the insulation, ends up being a big bypass. So that's a detail that ought to go on SIPS.
Good point. Good point.
Yeah.
Yeah. Very good point. Yes.
So, not to ruin everybody's bag-on section or session with all these different building materials, but if you install any building material incorrectly, it's going to perform poorly and not as effectively. If you put plumbing in any exterior wall, you're displacing the insulation in that exterior wall, and the whole assembly is not going to function as well. Running electrical through any exterior wall is going to displace energy. It's more so true in fiberglass than it is in any other insulation method except for maybe rock wool, where it's even harder to fit it around the electrical and stuff like that. Anybody who designs or uses SIPs in a regular basis is going to look at the design of the house and determine if it's a good structure to use with SIPs. And then they're going to design their chases, vertical and horizontal, to make it so they don't have to cut a bunch of holes in it for electrical. And any project that I see, I always recommend that they don't put plumbing in the exterior walls.
Yeah.
Because it always screws up the installation. And so I think it's easy to just sit there and rip on all the possible ways to screw up a building. There's tremendous numbers of possible ways, but if you get people that know how to use SIFs, or know how to use rock wall, or know how to use fiberglass insulation, or blown-in bib, or whatever, they're going to produce a better product than somebody who doesn't.
Right.
And experience means a lot in this industry. And with the spray foam, I mean, you don't get guys that don't know how to use spray foam to put in spray foam because they do a really poor job. But you can get guys that can do a really good job of putting in spray foam. And if you are diligent about picking out the materials that you use, and you don't, for instance, use closed cell unless you absolutely have to, because of the global warming potential. Now, Honeywell's coming out with a propellant or a refrigerant that you put into closed cell that's going to produce a much better closed cell foam without a giant global warming potential, which historically has been the fact. But open cell foam uses air as the refrigerant. It's actually called the blowing agent. And the global warming potential of that is 1, right? It's air. So it's easy to just rip on everything and every building material, but if you pay attention, I think everybody here is probably in that group that pays attention to how they're building their houses, otherwise you wouldn't be here. And you can produce really high efficiency, super diligent, potentially passive house homes if you're incredibly attentive to those details with pretty much any material.
I greatly appreciate that comment, and I agree with every single word. And I would like to add kind of a disclaimer. I'm not eliciting these comments to diss various construction assemblies because I don't think the construction assemblies are good. I'm eliciting this conversation so we can learn where things are vulnerable, and so we can all make better decisions about which things to use in certain situations, how to assemble them, so we can all learn. It's about learning. That's the intent. And there is no perfect single silver bullet. Every detail we've looked at is some sort of compromise. It's a trade-off. It's design. It's designating what our intent is going to be. That's design. And thank you for kind of bringing that to the forefront. We're not dissing on any of these things in any sort of absolute way. We're looking to learn as much as we can. Gavin.
Yeah, I totally agree with that. I think that one of the things we want to do is we want to look at the stuff that we've done the most of in the past as a construction industry, which in North America tends to be wood framing, and look at all of the mistakes that we've made, the things that have led to issues. Oftentimes we're just recreating those same mistakes with other materials that we have less experience with. And so I think the value in looking specifically at areas that materials are prone to weakness is that oftentimes folks think, well, now that we're switching from wood framing, we won't have the problems that we have had with that. This new product is going to take care of that.
Right.
It's usually not the case. It's lack of attention to detail and understanding what details to look for.
Right. So actually, we need to bring this to a close for this session. I greatly appreciate you bringing that up at the very end. It's kind of a nice way to clarify what we're doing here for this. Sam has to get on his way to go do other things. We're greatly appreciative that he's been here today. And actually, Gavin, you're here for the rest of
just today.
A couple more hours today. So anyway, we're going to wrap this one up, take a little break, reorient things, and have actually, we're going to figure out how we're going to do our next presentations. And you're going to have two of them, I know. So.
I don't know why it's two, but that's okay.
Or combined.
We'll just keep talking. I'll just keep, everybody wants to keep talking, we'll keep talking.
We will keep talking in all the ways that we do. So, but we'll just have a little break.
Please turn your evaluations into the back.